Okay, here's my mess on a bench. Now, what I got, a rotoverter, when it runs just free, it's 20 milliamps. Right now I have from the run cap a 3.5 UF. From that run cap I have these two yellow wires in parallel to the run cap. I tried series. Series hasn't been working for me right now. And so it comes out parallel. It goes to the high voltage side of this microwave oven transformer. This yellow wire and the other yellow wire goes to the high voltage side, parallel to the run cap. This is a modified microwave oven transformer. I pulled off this lid and took out the shunt bars and the shunt windings that'll be in here, and I put in a wrap of winds of the same gauge wire. And this gives it about 1.5 volts more. So this is coming out of the low voltage side of this microwave oven transformer. This gets pumped into a full wave bridge rectifier to make it into DC. And I have 8.2 volts coming out of this, 8.2 volts DC. The DC of this, without any cap or anything, goes right into this DC to DC boost converter. Then I twiddled the voltage knob to make it 15 volts, 15 volts. And then I have the DC output of the DC boost converter go straight into this battery to charge it. This battery's at 12.3 right now. And here's the current going into the battery, which isn't very good. It's like 30 to 20 milliamps. And I was talking to Hector. He says what you want to do when you tune it with caps is you want to be looking at the current going in and the current going out into the load. And he said you might as well start out with the battery as the load, so I'm doing that. So I can't spend too much time on this right now, but I'm going to show you a quick test of what to expect. I changed the run cap by adding this 5 UF cap in parallel to the run cap. This will take it up to 8.5 for the run cap. And I'm supposed to have some, they're called series coupling capacitors, like in series on one of the AC lines also. But I don't right now. I'm doing a parallel cap, so I'm going to boost the run cap up to 8.5 UF from 3.5 UF, okay? Now watch what happens. Dun-da-da. Okay, when I touch this, I put in the 5 UF cap. So you hear this changing tone. Now, I've got 210 milliamps pumping into the battery and 15 volts from the DC converter. So now we've got some good current. However, look what happened to the input. It's gone up to 360 milliamps. So let's try another. Let's try, instead of a 5, let's put a 4 there. Now this is better. Now it's just 280 milliamps, and there's 210 milliamps going into the battery and 15 volts. And we're running on 120, so that's a lot of watts. So let's try a 2 US. We're going to raise it up to 5.5 US. Now this is nice. Only 120 milliamps going in from the grid, while there's 160 milliamps going into the battery. So let's try a 1. And what I'm doing is I'm putting this in parallel to the run cap to change the UF value of the run cap. Now what do I get? Now this isn't too bad. 110 milliamps going into that battery to charge it, and 15 volts, while the input has gone to 0.08, which is pretty good. Not that good. If it was 0.02, that would be really good, but it's not. So what I've done here is just change the run cap values, and you see how it affects the output and it affects the input. And I gotta go. I'll get on this tomorrow, and I'll be doing series casts. I have another microwave oven transformer here also. Also, I tried this power supply. I was hoping this would, but it didn't work at all. Might be broken. Okay, so that's the test for the day. Thanks very much for watching.